Tennis Only by Charlotte Abood. The client is a tennis sporting company, Tennis Only, that sells tennis gear, where the logo will be featured on products including clothing and equipment. They also provide tennis lessons where the logo is used for advertising and promotions. The logo clearly reflects this through the feature of the tennis ball, tennis racket, and abstract tennis court. The inclusion of these three symbols distinctly mirror what the company sells and provides, while remaining both aesthetic and simple. The tennis ball is featured in the abstract tennis court, with the tennis racket slightly above it. This is all the logo consists of, ensuring that it remains simple and effective. Straight lines in the logo. The following equations show the variety of straight lines used within the logo, all of which have the same gradient and are used to produce the border, the finer detail of the abstract court, and the handle of the racket. The requirement of the two inverse functions were also both straight lines, which are clearly labelled. Absolute value graphs in the logo. As seen, I only featured one absolute value graph, and I used it to produce one of the sides of the court. Parabolas in the logo. As seen, I also only featured one parabola, used to produce the line in the court and shape the ball. Trigonometric functions in my logo. I only featured one trigonometric function, which was the regular sine graph, to produce the underside of the court. Circles in my logo. I used a total of 3 circles. The first was used to create the ball, and the second and third were used to produce the racket. Hyperbolas in the logo. There were 3 hyperbolas used to add detailing. The first was in the ball, and the remaining 2 were in the racket. Steps taken to create the logo. Please pause the video on each slide for more detail. The first step was that I started with a trigonometric graph of sin and gave limits at each of the peaks. The second was the addition of an absolute value graph with the same vertex but translated up one value. The third step was the addition of a negative parabola that has the same vertex and limits at the intersections. Step 4 was the addition of the circle for the tennis ball, where I found the centre of the area between the graphs as explained on the screen, and made it the centre of the circle. Step 5 was the addition of the hyperbola in the circle with the asymptotes of the previous values. The limits were the intercepts. Step 6, I connected the absolute value graph and parabola with a straight line using point gradient method as shown. Step 7, I repeated the process but on the other side. Step 8, I added another 2 lines translated down 1 unit with the intersections as the limits. Step 9, I made the racket handle with a straight line. Step 10 was the addition of another 2 circles to form the top of the racket. They had the same equation, just different values for the radius. Step 11 was the 2 additions of hyperbolas. Both asymptotes were the center points of the circle. Step 12 was the addition of the first inverse function of y equals 0.98x minus 2, with limitations that centered it with the logo. Step 13 was adding another straight line of the same equation but translated down 1 unit. Step 14, I made another straight line and found the equation because it had the same gradient, just negative, and intersects at 1. Step 15 was another straight line of the same equation as 14, just translated down 1. Step 16, I used the point gradient formula to find the equation of another line, which was then used in step 17 to form the inside border line. Step 18, the final side of the border was made using point gradient formula as shown, and again is used in step 19 to form the last line of the border. Step 20 was making the first shaded side by making the equation y equals more than negative 0.98x plus 1, which shaded everything less than line 1, but because it needed to be more than line 2, I got the equation that is shown on the screen. The limits were then taken as the furthest x values, which were negative 1 and 4.7. The final step was shading the opposite side, which was the same process as step 20 and can be seen on the screen. Points of intersections and their importance. As shown through the guided steps of creating my logo, the points of intersection had a crucial role in determining limits. In my logo, instead of the graphs intersecting and passing through each other, they all stopped when they got to another graph. This was executed through the use of intersections. One example is demonstrated below. The parabola was to stop at intersections of the trigonometric graph, which were these values, which in turn created my limits. The equation is shown on the screen. Thank you.